Fala. It's a great honor for me to be here today in the land of my ancestors. I actually am of Macedonian extraction. My grandparents were Sephardic Jews born in Bitola, and they lived in this land for 400 years. So I start off with a picture of what was their homeland as it looked about the time that they lived there. And just a little family background, one of my distant cousins, first cousin 3 times removed, was Raphael Moshe Kamchi. He was born in Bitola and was a Macedonian patriot that was involved in the Linden uprising for Macedonian independence in 1903. His nephew, another cousin, was a Zionist leader in Bitola and was responsible for getting many young people out who emigrated to Israel before World War II, but he himself stayed and died with his family and other people in the city. On the left is my great-grandfather, Rachamin Bochor Russo, one of his sons, Aaron Russo, his wife and son, who unfortunately died in Treblinka after transport under the Bulgarian and Nazi occupation. On a nicer note, Rosa Kamchi here is a third cousin. She was born the same year as my father, 1922, in Bitola. And she and her future husband, Benno Russo, who is not related, were members of the resistance in World War II, both surviving, and he went on to become a general in the army. If you have not been to the Museum of Remembrance in downtown Skopje, there's a wonderful film there that's also available online at this link that tells their story. And with that, we'll get back to the subject at hand. Cannabis sativa. Cannabis, of course, in various languages means aromatic reed or something of this sort. Sativa means cultivated. This is one of the most versatile plants on earth. It provides food in the seed. It was used in Eastern Europe for that purpose and still in China. The seed oil makes a fuel. Fiber, of course, from the stalks of the plant, and pharmacy, the use medicinally, which is our subject today. The real medicinal part of the plant are the unfertilized female flowering tops, as seen here. With this, since the plant cannot make seeds, it puts all its effort into producing cannabinoids and terpenoids in a futile effort to become fertilized. And we see here, as you've heard, the glandular trichomes on the ends of these stalks where the cannabinoids and terpenoids are produced. The distribution of cannabinoids in the plant is very important. It's almost all concentrated in the flowering tops. As you'll see in this graphic, in the leaves below, it's quite a bit less, and very little in the stems and none in the roots. There are some companies elsewhere in the world that try to extract cannabinoids from the stalks and other refuse of hemp culture, but this is a very poor way of cannabinoid production. I have been very interested in the interplay of the different chemicals in cannabis, what's called cannabis synergy. There was a concept developed by Professor Meshulam that related to the endogenous cannabinoids and how there were main players and others that were inactive on their own that produced an entourage, a boosting effect. And he said this type of synergism may play a role in the widely held but not experimentally based view that in some cases plants are better drugs than the natural products isolated from them. Well, that statement was made in 1999, and there's considerable amount of evidence subsequently that indicates that there is this synergy and it has been demonstrated. Prior to a few years ago, almost all cannabis that was available, especially in the US and also in Europe, were chemovars, chemical varieties, sometimes called strains incorrectly. But they were all very high in THC to the exclusion of cannabidiol or other cannabinoids. But patients would say that there was a great difference between this one and that one in its effects, but they were all high in THC, so the difference had to be explained by something else, and that would have to do with other chemical components called terpenoids that we're going to discuss. This is the biosynthetic pathway of cannabis, and if you see geranyl pyrophosphate in the middle, it's the key player. It will combine with olivotolic acid to produce the acidic cannabinoids, cannabidiolic acid, which then can either go to delta-9 tetrahydrocannabinolic acid or cannabidiolic acid. Again, this is the way they appear in the plant, and it's only after subsequent heating or aging that the carbon dioxide is lost, a decarboxylation that produces the neutral cannabinoids that are more familiar. But geranyl pyrophosphate is also a parent compound to the terpenoids, as we will discuss. Why does the plant make these? Well, we like to anthropomorphize, or people do, but in fact, this plant is about 63 million years old evolutionarily, and humans are much younger. So it wasn't put here for our purposes. It was put here, as most species are, to try to reproduce and establish a role in the world. But through an accident of fate, these chemicals that the plant makes at great expense metabolically are important to its future. Some of the components will attract bugs. Many of them repel bugs or even kill them, and this includes THCA, the precursor of THC, and CBGA, both of which kill insects. The trichomes are sticky, and if an insect touches them, it will get trapped. Between that and the chemicals, it will kill the bugs for the most part. Additionally, THCA will rain down on lower leaves of the plant and produce a pruning effect so that you go from the bush that you see on the bottom to a scraggly looking plant on the right that's, again, trying to just become fertilized before it dies, because this is an annual plant. An amazing one that can grow to 6 meters in some instances in one season. Again, the most familiar cannabinoid is delta-9 tetrahydrocannabinol, or THC. As you've heard, it was isolated in 1964. It is a weak partial agonist at both CB1 and CB2. One of its most prominent effects is as an analgesic, but it's also a bronchodilator. In the 19th century, there were cannabis-based cigarettes that were used to treat asthma. It's a very prominent neuroprotective antioxidant, and there have been studies demonstrating its ability to reduce brain damage after strokes or traumatic brain injury. It also on its own, not through the receptors, has 20 times the anti-inflammatory power of aspirin and twice that of hydrocortisone. It's a prominent muscle relaxant, which is responsible for the beneficial effect in spasticity in MS, which is the approved indication for Sativex in 27 countries. And of course, it's an antiemetic used to prevent vomiting after chemotherapy. And as you know, it's the primary psychoactive component. It does all these things without being a COX-1 or COX-2 inhibitor, so it does not produce ulcers or strokes or heart attacks as a COX-1 or COX-2 inhibitors may. So that was one slide on THC. Cannabidiol, or CBD, actually has a much more varied pharmacology. Although it was first isolated in 1940, again, the actual structure was elucidated in 1963 by Professor Meshulam. It barely binds in the regular sites, the orthosteric site of CB1 or CB2. So how it worked in opposition to THC was not recognized for a long time, but it was known that when it was present, even in small amounts, it would have an antagonistic effect on THC. Last year, this was finally discovered, and it is a negative allosteric modulator. There is a second site on the receptor that modifies the function. So this is a very interesting relationship. It also is a very prominent neuroprotective antioxidant, and it's stronger than vitamin C or vitamin E in this regard. We heard mentioned before, this is a TRPV1 agonist like capsaicin, and in chronic use should have the ability to reduce certain kinds of neuropathic pain. One of the most interesting effects is that it inhibits the uptake of anandamide, the best known endogenous cannabinoid, and weakly inhibits its hydrolysis. So it has an effect akin to what the selective serotonin reuptake inhibitors do with serotonin. It also is, in low and moderate doses, an alerting compound that is in opposition to the sleep-inducing effects of THC. It is a prominent anticonvulsant, and as you've heard, Epidiolex, a primarily CBD product, is in phase 3 clinical trials now for treatment of Dravet syndrome and Lennox-Gastaut syndrome in children. Unlike THC, which at high doses produces anxiety, cannabidiol is anti-anxiety. It shares with other cannabinoids a very interesting property in that it's cytotoxic for a variety of cancer cell lines at high concentrations. Small amounts won't necessarily do this, but at the same time, it preserves the normal cells that surround the tumor. So this is quite distinct from conventional chemotherapy agents, which are generally toxic, and you have to hope that you kill the tumor before you kill the patient, or their hair follicles, or their gut lining. Cannabidiol also antagonizes tumor necrosis factor alpha, and this is important in a variety of autoimmune diseases such as rheumatoid arthritis and inflammatory bowel diseases. Again, not a COX-1 or COX-2 inhibitor. A wide variety of cannabidiol effects are mediated through the serotonin 1A receptor. I hypothesized this relationship some years ago, and we were able to demonstrate it, and it is the main mechanism of action of CBD on nausea, in reducing effects, damage of stroke, and a variety of other mechanisms. It also enhances adenosine receptor A2A signaling, which may be related to some of its anti-inflammatory and analgesic effects. Although these are not common, it seems to have activity against slow viruses, prions. An interesting recent discovery was that it stimulates bone fracture healing, and perhaps in countries where it's not forbidden, which include the USA, this could be an acute treatment for bone breaks. There are a lot of misconceptions about cannabidiol, and these are widely promulgated on the internet. Again, a lot of companies will say, oh, we have this small amount of CBD. It's actually usually not enough to be pharmacologically effective. In comparison to THC, it's a relatively less potent molecule, and it's better to have a larger amount. We'll also hear it's sedative. It is not. This has been demonstrated by experiments with electroencephalography. It will oppose the activity of THC and is actually quite alerting when used on its own. A lot of types of cannabis that are rich in CBD will also be high in myrcene, which is a sedating molecule itself, and this creates confusion. There have been recent articles alleging that CBD turns into THC in the body. It's been known for decades that you can make THC from CBD in the presence of strong acids, but there's no evidence at all that this occurs in vivo in humans. It just does not. The levels of THC that have been measured in the serum of patients getting CBD have always been commensurate with a tiny amount of CBD present in the natural material and not due to bioconversion, because there's no enzyme that will make that conversion. Another molecule you may not have heard as much about is tetrahydrocannabivarin. It's similar to THC, but it has a 3-carbon side chain instead of 5. And that changes its pharmacology quite a bit. It is an antagonist at low and moderate doses, and then turns into an agonist at CB1 at high doses. This is known as a biphasic effect, and it's one of the quirks, the unusual natures of cannabinoid pharmacology, that there may be opposite effects at radically different dosage ranges. This is a very interesting molecule in that it has been used clinically in metabolic syndrome and in diabetics. It does improve parameters related to those kinds of things and does reduce hunger. It also is a prominent anticonvulsant, although it hasn't been tested clinically. It does demonstrate these effects in the lab and in animals. Can decrease edema and hyperalgesia, so it portends to be an interesting agent of the future. As THC needs to be decarboxylated, the acid form in the plant, tetrahydrocannabinolic acid, is freely available in the raw material. As mentioned, this is insecticidal, but it's also a prominent anti-inflammatory via the anti-tumor necrosis factor alpha effect. A very interesting phenomenon is, back in 1978, it was reported that this was anticonvulsant, but only at a very high dose, 200 milligrams per kilogram. However, there's a lot of good clinical information now coming from doctors in the US indicating that it seems to have prominent effect against seizures in humans at a very low dose. And this has been with measured material showing THCA, but no THC. So again, it may have a multiphasic effect, or there may be some other mechanism operative that needs to be explored. So this again is an area that needs to be researched. Its counterpart is cannabidiolic acid. So this would be the most prominent phytocannabinoid in raw hemp, as you would find in the field in Macedonia. It's a natural herbicide. It is an extremely potent antiemetic. It's actually a couple of orders of magnitude stronger than THC or CBD against vomiting. Although that was discovered several years ago, nobody has tested this in humans yet. Also, in medieval and Renaissance Europe, there were a lot of indications. The herbalists would claim that this is very effective in treating tumors, growths of various kinds, and that's another area that remains to be fully explored with modern techniques. Now I'd like to shift into the terpenoids. This is the largest group of plant chemicals. There are about 20,000 characterized. There have been 200 different ones found in cannabis, but there's certain ones that are most common, about a dozen. These are produced by the plant in different parts as part of its defense to attract animal or repel animals. They're very expensive for the plant to make, so they're just not there by accident. They usually are in sequestered structures, and we have the glandular trichomes on these stalks in the flowering tops because, again, that material is toxic to the plant itself and has to be held away from it. Most of the terpenoids are highly lipophilic and cross the blood-brain barrier, so they have psychoactive effects potentially. These have often been ignored pharmacologically in the past because the amounts that are present are tiny. It's generally about 1/7 or less of the concentration of the cannabinoids. However, it's been demonstrated that concentrations as low as 0.5% will produce pharmacological effects that are measurable. Pinene, that we'll talk about later, is the most widely distributed terpenoid in nature, but it's rare in cannabis. Limonene is the second most common, and again, it appears in some cannabis and some not. We can say generally that almost all the terpenoids are safe. These are the essential oils that give plants their aroma and some of their taste. It has been demonstrated, there's some countries that use gamma irradiation to sterilize the cannabis after it's picked. This is to reduce coliform counts. It is certainly possible with clean culture to grow cannabis that has no significant coliform counts. So I would maintain that this technique should not be necessary with the best culture, but it has been demonstrated that gamma irradiation reduces the terpenoid content of the material, and this may be undesirable. This is a graphic from an article I had published in 2011, and you'll see some familiar plants there with the corresponding essential oil components, the terpenoids, that are found also in cannabis. So certain of these are analgesic in their own right via certain mechanisms we'll discuss. Many enhance mood as antidepressants or anti-anxiety agents, and certainly they modulate THC, producing synergy with the phytocannabinoids. The first we'll discuss is limonene, familiar to you as lemon scent. Any citrus, if you take your thumbnail across it and release the trichomes, you'll get the aroma. Also put in all detergents because psychologically we equate this scent with things that are clean and fresh. This agent, when wafted into the air, has a very pronounced antidepressant and immune stimulating effect. It was demonstrated in a clinical study in Japan where hospitalized depressed patients cut their depression scores in half, and many were able to get off of their standard antidepressant medicines. And the same things have been demonstrated in the brain in rodents. There was a clinical trial, phase 2, to look at treatment with high doses of limonene in breast cancer. It wasn't particularly successful, although it was tolerated. A lot of things, as you know, in vivo will be cytotoxic, but don't pan out as medicines for humans. I think here that the limonene would have been far more effective if they had tried it with accompanying cannabinoids, but that's been yet to be done. Citrus essential oils with limonene in them are quite effective against dermatophytes, skin fungus, which are normally very hard to treat. This is well taken up by the pulmonary route, but also will get through the skin and is absorbed also through the gut. When you see GRAS, G-R-A-S on all of these, that means the designation of generally recognized as safe by the American Food and Drug Administration or other agencies. Probably the most common terpenoid seen in cannabis these days is this one. This is myrcene. And it also appears in hops, which is the closest relative of cannabis. We don't usually think of hops as being sedating, but hop pillows are still used in some areas of Germany as a sleep aid. This does block inflammation via prostaglandin E2, and it has analgesic effects in mice that interestingly are antagonized by naloxone, the opioid antagonist. So it has a definite narcotic effect, and this is notable in humans where it's sedating, has muscle relaxant effects, and it will prolong sleep time. In the States, we have an expression, certain kinds of cannabis will produce couch lock. This is a way of saying that when somebody takes it, they can no longer move. This might be helpful if someone needs to sleep, but it's not an advantage for most patients that would like to take their medicine and be able to work or study and get up and move. So in general, this is a good component to have less of in many instances. As I had mentioned previously, something we don't see a lot of these days is alpha-pinene. Very prevalent in nature, but rare in cannabis these days, which is too bad. This is anti-inflammatory in its own right, this time with prostaglandin E1. It is a bronchodilator, and with THC might be useful by a route other than smoking for bronchoconstriction. Its most interesting activity is as an acetylcholinesterase inhibitor. As you know, acetylcholine is the memory molecule in the brain, and quite prominently, THC produces short-term memory loss because of its anticholinergic effects. If pinene is present, it can oppose that activity and allow a person to work or study with THC. It also is a wide-spectrum antibiotic. Another familiar one is linalool. This is present in lavender, about half of its essential oil component. This is a prominent anti-anxiety agent, and it is sedative on inhalation in mice. It also has a very prominent local anesthetic effect. About 100 years ago, it was noted that essential oil of lavender, when applied right after a burn with cooling, would prevent blistering, and this is quite effective, a good thing to have in the kitchen. It also has prominent anticonvulsant effects, and again, we now have anecdotal information in humans that cannabis with linalool in it may be more effective as an anticonvulsant. A fascinating agent is beta-caryophyllene. This is a sesquiterpenoid. It has 15 carbons, unlike the 10 carbon ones we've seen previously. Again, an anti-inflammatory via prostaglandin E1. It's comparable in potency to phenylbutazone, which is used in horses as a non-steroidal. But unlike the non-steroidals, it protects the stomach against ulceration. This has been used traditionally in some areas of the world, particularly South America, as copaiba balsam for anti-inflammatory and analgesic effects, but it's also prominent in black pepper, as we see here. About 10 years ago, it was discovered that caryophyllene is not just a terpenoid, but it's a cannabinoid also, because it is a relatively strong full agonist at the CB2 receptor. As you know, that is the non-psychoactive receptor that's important in pain and inflammation. And this has been demonstrated in animals as well. Could be quite useful in contact dermatitis, which has a combination of CB1 and CB2 activity at its root. Its close relative is caryophyllene oxide. I'll just mention two things about this. One is that when dogs are used to sniff for drugs, this is the agent that they identify. It also is very powerful in treating nail fungus, onychomycosis, and may be much more effective than the very expensive drugs that are on the market now, which have a very limited efficacy. Now, I want to shift gears a little bit. There's quite a debate about whether there's more than one cannabis species. This debate's been going on a long time. One classification is this. Type 1 cannabis would be those high in THC. So this is what would be commonly present on the black market. What was more common in the past were type 2 plants, where there was a mixed THC, CBD, generally about 1-to-1. And then hemp was typically type 3, CBD predominant, and now there's selective breeding to make plants that are high in CBD to the exclusion of THC as well. But the debate on the species goes back several hundred years. Cannabis sativa was described as such by Leonhard Fuchs about 250 years before Linnaeus, but he usually gets the credit for the name. But about 25 years later, however, Antoine Lamarck in France described what he felt was a separate species called Cannabis indica that we see on the right. But please note that although it's a bushier plant, it has narrow leaves. This was plant material brought from India. Subsequently, one of my mentors, Professor Schultes at Harvard, went to Afghanistan and published this article showing the shape that you've seen previously this morning, with the sativa, long and lanky plant, the indica being a short and squat plant that he found in Afghanistan as in the picture. But this does not look like what Lamarck described at all. It's a broadleaf plant. And then ruderalis, a 1 meter or less unbranched plant. So this created a lot of confusion, and what we've ended up with today, decades later, is that these terms are used unscientifically. And I would urge you not to characterize things as indica or sativa, because from a scientific standpoint, it's not supported at this time. Let me give you examples. We see David Watson here with a very tall plant. Looks like a sativa, I guess. It's actually a Chinese hemp origin plant. If we look closely, it has wide leaves like the so-called indica. And then in Morocco, I took this picture where the plants don't receive a lot of care, no water, no fertilizer, and they're unbranched about 1 meter high like ruderalis. But under other conditions, they would look different. So you really cannot tell what the plant is by its shape. Rather, you need to know the chemical content. When this is done, it's interesting that the thing that tells one cannabis type from another isn't so much the cannabinoids, but terpenoids provide the best distinction between the different types. But whether those can be called species or not is still debated. I would paraphrase an old Yiddish expression and say that if you have 12 botanical taxonomists, you'll get 25 different opinions on cannabis. What would be a better scheme? Well, I think that this would be one in which you describe the shape of the plant and its leaflets. You would describe its basic cannabinoid chemistry, such as type 1 for high THC, what the plant's shape is, again, the leaflets being broad or narrow, what the cannabinoid content is, what the specific terpenoid content is, how it smells, how it tastes when it's vaporized, and what's it good for in terms of its therapeutic potential. One such scheme is that we see published in this article and on the right in graphic form. And you see at the top, I hope that you can make these out, the cannabinoid percentage of 23.3%, terpenoids 2.5%, which is relatively high, moisture content, a picture of the buds, a listing of the primary cannabinoids with their percentages, and then in the third panel, we've got a picture of black pepper and lemons, indicating that this has scents like black pepper and lemons due to the limonene content. We also have a description of the effects from patients who have used this. You see that this one's high in comfort and relaxation is low. So it's not a sedating one. And then we have the specific terpenoid content, and this is rarely available even in the United States. I think that this is essential to a patient knowing what they're getting and how it might affect them before they try it. In the yellow bar, you see that this is very rich in limonene, which suggests to me that this would have a mood elevating effect and would be good for the patient who had depression with their other symptoms. The blue bar is also very high, caryophyllene, so this should be very good for treating pain and inflammation. At the bottom, the purple is very low in myrcene, so this would not produce couch lock and might be a kind of cannabis that would be good for the chronic pain patient that needs to be alert and able to concentrate. I want to discuss a little bit about landraces. Landraces are cannabis types that have grown in an area traditionally over many generations, not a few years. And so there should be landraces of cannabis that have been present in Macedonia probably since the time of the ancient Thracians, because we know that they had this from descriptions in the ancient literature. So these are ecologically adapted to the local conditions. They may know how to produce the terpenoids that ward off the bugs that would like to be predators on it here. A lot of the useful medicinal properties of cannabis have been lost from places like Jamaica, Colombia, Morocco, Afghanistan, and Thailand, because the land races that previously grew there have been replaced by seeds from California and the Netherlands that are pretty much all alike. High in THC, high in myrcene, to the exclusion of things that might be more useful in terms of their components. So I hope that the land races of Macedonia will be preserved because they may have unique attributes that will be helpful. Again, I'd like to shift gears and talk about some interesting effects of agents beyond THC. This is a study that was related to a phenomenon where they found out that people with damage to the insula in the brain from strokes or head injury who were smokers of cigarettes could suddenly stop and not have craving. And this is extremely unusual. They found out that the insula seems to be an important mediator of addiction, and particularly craving in relation to that. And it's not just for tobacco. The same applies to cocaine, alcohol, and the opioids. Well, how is that important for cannabinoids? Well, this scan shows us that a very high dose of 600 milligrams of cannabidiol functionally will inhibit the insula, as we see in this scan. And even at this high dose, there was no accompanying sedation or psychoactive changes in terms of side effects. So this suggests, among other reasons, that cannabidiol could be an excellent agent in treating addictions to other substances. It's something that we'd like to investigate. It's also been shown that when there is a significant amount of CBD in cannabis that people use recreationally, it would reduce liking for drug-related stimuli such as food. The authors of this study thought that it would also apply to other drugs of abuse and again help reduce alcoholism or other dependencies. Looking at another agent, again, we're always on the lookout for drugs that could help people stop smoking. In general, most of them work, if they work at all, just until they're stopped when people relapse. But they thought maybe if people inhaled black pepper essential oil, that this would help. And in fact, it did. They thought it was because it's irritating like cigarette smoke. But let's keep in mind that the black pepper contains a lot of essential oils, including pinene, which would make someone more alert, myrcene, that would make them sedated, and caryophyllene, that is a CB2 agonist, as we've mentioned. Well, how does that work in relation to dependency? Well, this study was done with a synthetic agent, JWH-133, that is a CB2 agonist. And in animals, they were able to show that when this was applied via a variety of techniques, that it inhibited dopamine release and cocaine self-administration in the mice. And it's clear that caryophyllene should work in the same way. However, because it's a natural compound, there's less incentive for a company to try and use it this way, because it would be hard for them to create a monopoly on the natural product, which is a shame. We're often asked, what do you do when someone has too much THC, has an overdose on cannabis For the most part, these are self-limited affairs. If you wait a few hours and the patient is talked down, that's usually all that's required. Exceptionally, they might need to be sedated with a benzodiazepine, but generally not. I would maintain that we can help avoid this problem if cannabis is better constituted with the correct ingredients. So we've got some evidence from the past. From Persia, we have this. To avoid these harms from ingestion of cannabis seeds and hashish, one should drink fresh water and ice or eat any acid fruit, such as citrus. Much later, from North Africa, this doctor described that when hashish needed to be neutralized, that lemon juice would work. But it wasn't just lemon juice. From Morocco, nearby, there's this recipe for what they call agua limon, lemon water, again from the Sephardic Jews, this recipe. And it wasn't just lemon juice, but the recipe calls for the zest of 7 lemons. That's a lot of limonene, and I think it would be an effective antidote to an overdose of cannabis. But there are others. From the Ayurvedic literature in India, there's a description of the use of calamus root to neutralize the effects of cannabis. This is what it looks like. And the way that works is that there is an ingredient called beta-acerone that is an acetylcholinesterase inhibitor. It's weaker than physostigmine, which is a drug used for myasthenia gravis and can have a lot of bad side effects if there's too much. But beta-acerone is weaker. But instead of calamus, if we have a cannabis that has a good amount of pinene in it, as certain chemovars do, this will help prevent the short-term memory loss, as mentioned. And I had more evidence from the past. Pliny the Elder described galatophilus, leaves of laughter, growing in the area that's now Afghanistan today. And he described the effects of this as producing all kinds of phantoms that beset the mind, causing laughter, which would go on until the antidote was administered, which was pine nuts with pepper and honey and palm wine. Well, I'm a very analytical type of person, and I wanted to look into this further. Why palm wine? Well, the ethanol wouldn't help. A combination of ethanol and THC is not a very healthful one most of the time. Ancient wines were stored in clay pots or goat skins and required preservation, usually with pine tar, like retsina is still used in Greece today. The pine tar is rich in pinene. Another agent, terebinth, from the pistachio family, also is rich in limonene. And these days on the internet, you can find anything. I wanted a chemical analysis of the pine nuts that Pliny described, and this has been done. And we see the analysis here, and in fact, there were high contents of limonene, alpha, and beta-pinene in the pine nuts. Very prominently. And so I developed what I call the cannabis overdose antidote meal, which is pasta with pesto and the agua limon. So you get plenty of pinene and limonene that should be a good antidote to the cannabis overdose. Becoming serious again, let's talk a bit about different administration forms. Of course, smoking is the most prominent, but probably the least good for health. This is still illegal most places. It is the most likely to produce intoxication because of the rapid pharmacokinetic rise in serum and brain levels of THC. People say that it's easy to titrate, but not with modern material that's so potent, because generally the person will be intoxicated already with a dose that's higher than they might need for their symptom control. It's actually not very efficient. The bioavailability with smoking is somewhere between 10 and 30% generally. A lot of this is lost in side stream smoke. It produces aromatic hydrocarbons, which are potential carcinogens, although it must be stated that cannabis smoking alone is not a risk factor for lung cancer. When it is combined with tobacco, as is common still in Europe, it is a risk factor. However, it still is irritating to the bronchi and produces phlegm and tendency towards upper respiratory infections. In almost all countries, this kind of administration could not be approved by regulators. Additionally, there are dangers of smoking because of pesticide contamination. In this study by Sullivan et al., they applied pesticides to material with a smoking machine and found that 40 to 70% of the material would come out in the smoke and then be readily bioavailable by absorption by the bronchi. This is now a demonstration that even a so-called legal market, if it's not properly regulated, will create public health problems. I live in Washington State. There's now a legal cannabis market there, but we wanted to look at pesticide contamination and did a study in which 26 samples were taken from the legal market. This is all witnessed. 22 of these are concentrates, which are now the most popular way of using cannabis among the youth in certain areas in the United States. And so 24 were concentrates, 2 were flowers. These were sent to the lab, and unfortunately, 22 of 26, or 85%, tested positive for pesticides. And it wasn't small amounts. There were very high concentrations with multiple agents, often tens or hundreds of parts per billion, with some very dangerous chemicals. These were in various classes of insecticides, miticides, fungicides, including neonicotinoids, which are one of the things that are responsible for the colony collapse disorder that is decimating honeybee populations around the world. This is a table from an article that's just been published. The PDF is not online yet, but will be available open source. You're welcome to contact me via email, and I'll see that you get this. Hopefully, this will be available in the next few days. But these are the agents that were found. We'll just look at one. This is carbaryl, carbamate insecticide. This is a bad actor. It's a cholinase inhibitor, which in high amounts will produce seizures, even in someone who hasn't had a tendency. It's a known carcinogen, and it's a developmental and reproductive toxin, and a suspected endocrine disruptor. In this particular sample, the amount of this was 255 times the trace amount that would be allowed if any pesticide, synthetic pesticide, were allowed on cannabis, and actually none are. You may have heard of vaporization as an alternative to smoking. This does reduce some of the polyaromatic hydrocarbons, but to date, no study has shown their total elimination. You see the different effects at different temperatures in this machine called the Volcano. On the left, the untreated dried cannabis, then 175 degrees Celsius, 195 and 230, at which time it looks quite toasted but not quite burnt. A survey published a few years ago looked at use preferences among patients who use cannabis, and unfortunately, smoking still predominated, and although about half of medical users had tried vaporizers, only about 27% preferred them. So that's unfortunate in that it could be a useful form of harm reduction, and few had used them orally. Even though that lowers the risk even more as long as the dosing is wise. As mentioned, cannabis concentrates are becoming available in more areas. These can be extracted with polar solvents, but some of the solvents, particularly Benzene is highly flammable and explosive. We have accidents regularly in the US because this can only safely be done with a vacuum hood. In the process, THC and any contaminants like those pesticides are going to be highly concentrated, as we've seen. You may have heard of Rick Simpson oil. Rick Simpson oil is actually not a new technique, but his recommendation to use naphtha, a petroleum distillate, with a lot of contaminants is a very unwise choice because of toxic residues. Even patients who use dabs or concentrates will acknowledge that they develop tolerance to it very quickly and may have withdrawal symptoms. This is not a good technique for medical administration because it far exceeds the kinds of doses that are necessary for symptom control, such as reducing nausea or reducing pain. So this is a byproduct of prohibition, particularly more suited to the recreational market. But I think with better education, we can help avoid some problems with such preparations. Additional evidence. One of the kinds of concentrates is called wax because that's what it looks like, this tarry stuff on the left. In a vape pen, so-called, the unheated coil is in the middle, but when you press the button, it's red hot in seconds. That's not vaporization, that's burning, and again, will produce toxic byproducts. Unfortunately, some of the waxes don't smoke very well, and they're put in the vape pen with propellants like propylene glycol and formaldehyde. Propylene glycol in low amounts is not toxic orally, but it was never designed to be heated at high temperature and inhaled. And unfortunately, as in the study, using e-cigarettes with tobacco, it will form a significant amount of formaldehyde, a group 1 carcinogen, when it's used in this way. And it was estimated that this actually could be more carcinogenic than the cigarettes would be. Now, some dosing issues with THC and cannabis. The correct dose for someone using cannabis medicinally totally depends. It depends on whether they've used cannabis before, what their experience is, and their underlying endocannabinoid tone. How dense are their receptors? What's the concentration of anandamide in their brain? We don't have ways of measuring that right now in living people, but maybe in the future. The best advice is to start low and go slow. Almost always we're dealing with chronic diseases. I will tell a patient, look, we want you to get better, but it will be better for you and everyone if we get you better slowly, because if we produce side effects, you won't like the medicine, you won't continue, you will not benefit. We can say in general, and this varies, that 2.5 milligrams of THC is the threshold dose for most patients. 5 milligrams is usually efficacious and tolerated, but 10 is already too much for many patients unless they already have tolerance or experience. We know that even as little as 15 to 20 milligrams of pure THC will pose a risk of producing a toxic psychosis reaction. However, in the presence of cannabidiol and certain of the terpenoids, as you've seen, the therapeutic index can be much greater, as much as tripled, as was demonstrated in a study where it took 47 milligrams of THC with cannabidiol and terpenoids to produce toxic psychosis in a very small minority of patients. The best correct dose of a cannabis-based medicine is the lowest one that produces a therapeutic benefit without side effects. To finish up, I want to talk about where we are in the research area now. We have solid clinical proof for cannabinoid therapy using THC and CB1 agonists in the areas of nausea and vomiting, anorexia with chemotherapy or AIDS, for spasticity and multiple sclerosis and neurologic conditions, for cancer pain, and for lower urinary tract symptoms. For cannabidiol, we have evidence of benefit in intractable epilepsy and also schizophrenia, where it's beneficial in positive and negative symptoms, hallucinations, or slowness of movement. We have important research priorities. Pain and inflammation, that's 70% of patients in most surveys, particularly on studied conditions. Both major kinds of arthritis, osteoarthritis and inflammatory arthritis. Also inflammatory bowel disease, metabolic syndrome and insulin resistance. There are actually benefits of THC, but with THCV and CBD. The area of dermatology, acne, psoriasis, etc. Neuroprotection and dementia and traumatic brain injury and stroke. But it doesn't always require cannabis. There are ways of modulating the endocannabinoid system with diet and other herbal agent that could optimize endocannabinoid health and would reduce the need for cannabis. And maybe we have a little less controversy about this area of treatment. What we need in research is standardized, good manufacturing practice cannabis with appropriate cannabinoid and terpenoid profiles that are available to the patients or their doctors. We need genuine phase 2 and 3 clinical trials that meet standards of regulators for pharmaceutical development. Although they keep coming, we don't need a lot more case studies or surveys. These are interesting, but they don't represent proof that's suitable for most physicians or certainly for the regulators. And we don't need to be wasting public funds on studies that won't advance our knowledge in a significant way. So I'd like to close by saying it's critical to understand cannabis is a plant that modulates the endocannabinoid system, an innate homeostatic regulator of human physiology, but one that can also be influenced by other herbal agents, lifestyle, and dietary factors. And with that, I will close and thank you for your attention. Fala.